Hello! Have you heard that hydrogen has color? This is surprising actually, because this is a transparent gas. But in the media or in the news, you probably heard about black hydrogen, blue hydrogen, green hydrogen. So where does that come from? So why, first of all, hydrogen is interesting in the green transition? Well, perhaps you did the experiment. When you burn hydrogen, you can have energy, you can have heat, and you do not emit CO2 because you form actually water. So where does hydrogen come from? It can actually come from the fossil, from oil, from gas, from coal. This is, for example, what we call the black hydrogen. But we are not so much interested in this one at this stage. The one that is a bit more interesting for us is, for example, the green hydrogen. So this hydrogen actually comes from water. But we know that on Earth, if you mix hydrogen atoms together with oxygen atoms, we form a very well-known molecule, H2O. This is water. And this molecule is extremely stable, and we all know it. So the idea of the green hydrogen is to use green energy from solar cell or from wind turbine to break the water molecule into H2 and O2. And H2 then can be transported and used anytime, anywhere, even when the renewable energy is not working, for example, at night when there's no sun or when there's no wind. So hydrogen is not a source of energy. Hydrogen is actually a way to store and transport energy. We call it an energy vector. Actually, breaking the water molecule and producing hydrogen is not that easy. Of course, as we all know, the water molecule is very stable, which means that we have to overcome a high energy barrier. But don't worry, we can reduce the height of this energy barrier using what is called a catalyst. A catalyst will accelerate a reaction by actually lower the energy barrier. Unfortunately, for some of the technology for hydrogen production, the catalysts are metals that are precious or rare. If we take, for example, proton exchange membrane technology, it requires platinum and iridium. If you check in this graph, you see that it's only a few hundred grams of these metals per megawatts of power installed. This may not sound that much, but do you know how much platinum is produced? Actually, only 200 from mining and 50 from recycling. And what about iridium? Actually, iridium is only produced about 7 to 8 tons per year. This is very small. Do the math. The density of iridium is about 20. It means that it's a third of a cubic meter. This is a very small amount of metal produced every year, 7 tons. And the problem is that to develop the hydrogen economy, we will need more of these metals. And there are real questions how we are gonna find this metal. Let's have a look at the forecast of production of platinum. As you see, the total production is expected to be constant by about 250 tons per year. This is about 12 cubic meters. But if you look at the yellow line here, you will see that the primary production, which means the production from the mine, is decreasing quite much. It will reach by 2050 something like 120 tons per year. So this means that to maintain the production constant, we will have to raise the recycling rate from 20% today all the way to 50%, and that will only maintain the offer of platinum. But if we look at the demand now sector by sector, we see that the demand will be increasing very strongly, pushed quite much by the jewelry, but also by the energy. And the demand is expected to be largely overcoming the offer. Of course, this will not happen because the market will regulate by the shortage, but this may have very significant economic damage. So if the company doesn't receive their platinum, this will be a problem. You may say, why not replace platinum by one of their neighbor? Let's have a look in the Mendeleev table. What is around platinum? Well, you have osmium, you have iridium, you have ruthenium, you have rhodium, or you have palladium. Yes, they are similar and they are good catalysts. However, they are also together in the same ores. They are called byproduct. So iridium is a byproduct of platinum. It means that if you do not produce platinum, you do not have iridium. And when we will recycle platinum, we will not have any more iridium. So the production trend of iridium will not follow the purple line that you have here. It will show the decreasing yellow line of the primary production of platinum. So it is urgent to develop recycling of these metals or substitution. This is what we are going to see in the next episode.